So I'm going to give you a talk today on aliens and time travel. It's something I've been working on for a long, long time, even before I finished my PhD. So let's start with the aliens bit first. So let's start with what's called the Fermi Paradox by this guy called Enrico Fermi. So Fermi, he believed two things. And the first thing he believed was that there are lots and lots of alien civilizations. And the second thing he believed is that there aren't any alien civilizations. So we get the so-called paradox, the Fermi Paradox. So let's start with the first bit. Let's start with why he thought there were lots of alien civilizations. And the first thing to think about is to realize that we aren't that unusual. And this is something that people often forget. You should always default to thinking that, all things considered, you're a regular person in a regular situation. Now, you'll often come to believe otherwise. For instance, unlike many people, we're quite rich. And unlike many people throughout history, we're going to live a long time. And unlike many animals on the planet Earth, we can think and we can talk. So certainly, you can gain facts that make you come to believe that you're unusual in some respect. But that's not to say that unless you've got those facts, you should assume that you're kind of a regular person in a regular situation. So similarly, our planet doesn't seem to be that unusual. Indeed, in our solar system alone, one planet does support life. And three others, well, 2 planets and a moon, they come really close to supporting life. So figured our man Fermi. Amongst the 500 billion stars in our galaxy, a fair number are going to be likewise, and there's going to be a fair number of Earth-like planets that could support life. And indeed, there's people such as these people, the Kepler team, who spend their time hunting for these planets, and they found some with exciting names like, I'll have to look at my notes for this one, KOI 1681.01, or Gilly 667 CC. And presumably they're going to keep finding more and more as they look harder and harder, and hopefully watch a bit of Star Trek and get a bit more imaginative with what they call. Now, it doesn't seem that unusual either for life to actually evolve on the planets that are capable of supporting it. If we look at the history of our own planet, we see that life evolves as soon as it can. Single-celled organisms are a bit like advent calendars in Tesco. They appear as soon as it's cold and long before you even expect it. So we look back at our own history and we see that as soon as the roiling, boiling, hot creation of the Earth got cold enough, all these single-celled organisms appear. So the situation we're in doesn't appear to be that unusual, so we'd imagine that all these Earth-like planets out there are going to be the same. That as soon as life can appear on the Earth-like planets, it's going to appear. And all you need is for a small percentage of those planets to turn them single-celled organisms into intelligent life. And you're going to conclude that there's lots and lots of alien civilizations out there. Galactic hubs of activity spreading out across the sky. But, says Fermi, there isn't. When we look out, we see nothing. It's totally empty. It's totally silent. So thought Fermi, we had a paradox. We should expect there to be lots of alien life, but there seems to be a good reason to think that there isn't. So there must be some good reason about why there isn't any, which is either going to be some explanation of why we're actually unusual in some kind of way, or why there's an unusual explanation for why we're ordinary, but no one else is out there. So you might deny either part of this. So you might have been listening to this story and you might go, Nick, I'm not convinced, I'm going to deny some part of this. Maybe you're going to deny that the aliens are going to be quite as numerous as Fermi thought. Maybe you think there's a good reason for thinking that they're not. So maybe you think that alien civilizations, some sort of personal Armageddon befalls each one. And before they get to the stars, they just get wiped out by, say, war or disease or that kind of thing. But it's a bit odd to think that all of them end up like this. It's a bit odd to think that the chances of a disease that wipes out everyone on the planet, such that it never ever recovers ever. Or the idea that there's some sort of war that wipes absolutely everybody on the planet out of existence. That seems unlikely. It seems unlikely because, well, we're not unusual and, here we are. And at least in our case, if you met someone who thought there was going to be a disease that was going to wipe out the entire species at the drop of a hat, well, that's the kind of person who walks around in the rain with a sandwich board reading, the end is near and all of this kind of thing, and looking gloomy whenever the sun comes up in the morning. They're kind of odd people. It's kind of unusual to think that there's a disaster that will wipe everyone out. There's, of course, one exception, and that would, of course, be some sort of impact event from a comet or an asteroid. We know from our history that happens. We know that when that happens, just everything dies, and you're left with tiny little things, far smaller than us, that survive. But we'll come back to these asteroids in a second. We'll come back to these asteroids and why maybe this isn't so important. We'll come back to that in a second because I haven't really talked about the reasons for thinking that it's not likely that there's anyone out there. So you might be thinking that I've kind of anthropomorphized these people. I've kind of projected what I think people would be like. That I'm kind of suggesting that when we discovered radio, there should be some aliens on the other end ready to talk to us. And I mean, that's ridiculous. It's not like they've got iPhones or anything like that. But this is some kind of misunderstanding. This is some kind of Star Trek style lie that we've picked up from science fiction, that the aliens that are out there are going to be basically as well advanced as us or a few thousand years ahead. But that's actually thinking on a long time scale. If there's lots and lots of alien lives out there, lots and lots of alien civilizations, and they probably evolved millions upon millions of years ago, they're going to be far, far more advanced than us. So far advanced that they probably should have left the planet, their planet, years and years and years and years ago, you know, thousands upon years ago, and populated the entire galaxy. They should be everywhere. We should see them. In fact, it's probably the case that our ancestors probably should have been hunted for sport by them in some sort of safari. Right? That's the kind of thing you should expect. Or maybe you should expect that they came here for our resources. You know, you're an alien race, you come along this planet, there's no intelligent life, you're like, screw it, I'll mine it for all of its metals, I'll mine it for all of its hydrocarbons. I'll take all the things that we want from it. And that hasn't happened. So the things you'd expect to have happened if alien races had existed, if there were tons out there, it just hasn't happened. So presumably there aren't any, or there's an absolutely superb reason that doesn't occur to us for why they haven't done the things we'd expect them to do. Maybe you're going to complain again, you go, Nick, you're projecting, you think like humans do, why think that aliens are going to be a bit like Cliff Richard and go on a big summer holiday around the universe and say hello? Maybe they just don't want to do that. Why think that they're like the Klingon equivalent of BP and Shell, going from planet to planet, sucking out the natural resources? And the reason to think it is to go back to this asteroid. So asteroids explain why an alien civilization is going to do this kind of thing. Why is an alien civilization going to head out into the galaxy and see what's there? And that's because asteroids wipe out absolutely everything. And if you're a species that evolved in line with Darwinian evolution, that is to say, every species, you want to survive. So if you want to survive an asteroid smacking into your planet and wiping you all out, well, you're going to have to jump ship. You're going to have to jump ship and you're going to have to go to different planets. It's just a no-brainer. Eventually, you're going to have a problem on your own planet that you just can't avoid and you better get moving. Now, you might think that sounds ridiculous. Sure, it sounds too hard to go to other planets. But it's easy. It's easy to go to other planets. It's hard right now. But scientific advancements are going to take care of all of this. Again, if you think otherwise, you're just not thinking on the right time scale. So think of it like this. About 100 years ago, that was when we took our first plane flight in something that was made of the equivalent of lollipop sticks. And 110 years later, only 110 years later, we've got space flight, we've got satellites, we've got probes heading to other planets. And things aren't slowing down. Technology is just changing and advancing faster and faster. Just think how the internet or mobile phones were 20 years ago, and bearing that in mind, you should go, what's the chances of us being able to populate other planets? Well, if you don't think it's possible now, what about in 100 years? What about in 1,000? What about in 10,000? In 10,000 years' time, it should be a mere difficulty of simple engineering. We've got all the time in the world to figure out how to get to other planets, and we've got every reason in the world to go. That thinking should apply to everyone. They should be everywhere. There should be so much everywhere that we're not here at all to be asking the question. So that's the first part of the talk set up. The chance of a species-destroying event like an asteroid hitting a planet is quite small, and given that fact, it's kind of odd that there's not more alien species out there. Now, ironically, my answer is going to be that the chance of an asteroid smacking into the planet is incredibly, scarily huge. Right? Contrary to what I've just said, it's massive. And the reason for this has to do with time travel. So let's move to the second part of the talk, time travel. Now, I'm not going to talk about the physics of it. I'm a philosopher. You picked the wrong guy. But some physicists, serious physicists who write in serious journals, think that it's possible. They think that it's physically possible. So let's assume, just for the purpose of argument, that it's possible. And if we do that, we might wonder what is the case. We might wonder how this might set about solving the Fermi Paradox. After all, okay, it might be impossible, I might be wrong, heck, I might be wrong about a lot of things, but it's not insane, it's not ridiculous. It's worth spending, 20 minutes thinking about what would be the case if it were true. But here's a problem with time travel that I'm sure you may have come across yourselves, I'm sure you may have seen in films. So imagine time travel is possible. I could go back in time and kill my paternal grandfather before he impregnates my paternal grandmother with my dad. If that happened, then I wouldn't be born. If I wasn't born, how would I go back in time and kill my grandfather? This is called the grandfather paradox. So it's a second paradox we've got. And it's a paradox because we end up with a contradiction. So we end up with the following fact. In 1935, Walden Effingham, that's my granddad's name. My great-granddad was Walden Effingham. My granddad, my dad, firstborn brother. And then he was like, it's a ridiculous name, I'm not calling my son that. It ends here, the madness ends here. So in 1935, Walden Effingham is alive. But if I go back in time and kill him in 1934, then it's not the case that in 1935 Walden Effingham is alive. And we get a contradiction because it's then both is and isn't the case that Walden Effingham is alive in 1935. That's a contradiction. That can't possibly be true. But that doesn't mean it's impossible to travel in time. And the person who tells us why is this man, David Lewis. And for philosophers, David Lewis is the most famous and most influential of all philosophers. Now, you may have thought there'd be someone like Plato, or Descartes, Jean-Paul Sartre. When people say that to me, I always find it a bit weird. It's a bit like going, who's your favourite footballer? And you go, oh, it's Lord Sunderland, who played for James I back in, the 17th century. And it's like, why did you, there's so many footballers alive today. Why isn't one of them your favourite one? And philosophy's kind of like that. People don't realise it. It is, it's an active, living discipline. People who do philosophy don't just talk about what old dead people said. We're out there saying things of our own. And one of our luminaries is David Lewis, who unfortunately is dead. He died at the turn of the century, but only just recently. And he had a lot of things to say. He told us about why he thinks every possibility, like Harry Potter, is played out at some universe disconnected from our own. He told us why he thought it was reasonable for Christ to die on our sins on the cross. He wasn't a Christian, but he was like, yeah, it could be true. He wrote things on mathematics, on set theory. He wrote articles on why Hamlet has a shoe size. And he also wrote on the grandfather paradox. And he explained why it wasn't a problem. So imagine you've got a blacksmith, and I ask him to make an impossible object. There's an impossible object. For an example, let's not use that one. I don't know what that's called. Let's think of an impossible object as a round square. So I turn up to a blacksmith, I go, I need an object, from a girlfriend for our anniversary. What would you like? Ooh, I want something round, but I also want something square. Can you make me a round square? Obviously, he can't do that. It's impossible to make a round square. That would be a contradiction. But it is true that he can make something round, and it is true that he can make something square. He just can't do both at the same time. Lewis says time travel's just like that. You can go back in time, and I can kill my grandfather. I just can't go back in time and kill my grandfather. All the grandfather paradox tells us is that certain things are impossible. Things you always thought were impossible already, like going back in time and killing your grandfather before your dad was conceived. But that doesn't mean that time travel itself is impossible. So what would happen if I went back in time and tried to kill my grandfather? Well, Lewis says something's going to stop me. Right? Maybe my gun will jam. Maybe I'd accidentally shoot some other guy called Walden. Don't know what the chances are of that. Probably slim. Maybe I've got a stroke. Maybe I slip on the banana peel at the last minute and just miss. And indeed, that's what philosophers call these things, these events that get in the way of contradictions being brought about in time travel scenarios. They call them banana peels. So banana peel is just a placeholder for whatever unlikely event it is that stops us doing the impossible. So whatever happens, if you go back in time and try and kill your grandfather, you know that some sort of banana peel will stop you from doing it, because you know that the impossible can't happen. But here's a question that few philosophers have thought about, and I've thought about for a very long time. The University of Birmingham very kindly gave me 3 months to sit in Starbucks and think about, left completely alone to my own devices. You wouldn't believe it. What's the probability, even if it's possible? If it's probable, how probable is time travel? So imagine the following scenario. Imagine I give you a rifle and you're a good shot, and I get you to shoot some people. for fun. You've got a 90% chance of shooting a man dead. But you're not that great a shot, so you miss 9.99% of the time, and your genes aren't good, so you've got 0.01% chance having a stroke and dying randomly, and therefore missing. So imagine that's a setup. So I run all these people past you, and you gun them down with your rifle, and 1 in 10 run away calling for the police. And as you line up the tosshers on the very last person, I whisper in your ear that it's actually your grandfather that I brought back from the past before he impregnated your grandmother with you. What are you now thinking? What are you now thinking about the chances? As you're looking down the crosshairs, well, as you're looking down the crosshairs, you know that you're definitely not going to shoot him dead. You know you can't shoot him dead. You've not got a 90% chance of shooting him dead anymore. You've got a 0% chance of shooting him. So what happens? What happens to the other? What happens? Some sort of banana peel has to get in the way. Something has to stop you. And I've set it up that there's only 2 things that can stop you. You miss by chance, or you have a stroke. So what's the chance of those things? Well, clearly they rise proportionally. So the chance of missing is now 99.9%, 10 times greater than what it was. The chance of having a stroke is now 0.1%, 10 times greater than what it was. So what does this tell us? This tells us if I go back in time to try and kill my grandfather, the chance of some random illness striking me dead suddenly starts rocketing up. Right? It's bad for your health to try and shoot your grandfather in the past. That's what it tells us. This is what my claim is. So it's this bit of info. So I've done the two parts of talk. How do they go together? Well, it's this bit of info that tells us why there's no time travelers and why there's no aliens. So bear in mind what I'm saying. I'm saying that if you try and do the impossible, you can't, and the chance of the things that stop you will go up accordingly. So now imagine in the following scenario. You're the reporter, you've got a dictaphone, you sat there in some lab, watching scientists about to discover time travel. And let's say that at that moment in time, they're about to discover time travel. They haven't done it yet, they're about to. There's a 0.1% chance of an asteroid hit Earth and wiping us all out. Obviously that's a number I've plucked out the Earth. These numbers are placeholders, use whatever you want, but for ease of argument that'll do. Now if they discover time travel, if they do discover time travel, that means that loads and loads of people are going to go back in time and they're going to try and bring about contradictions. So maybe some of them will try and kill their grandfather. But it's not just killing grandfathers that might happen, right? Maybe I decide to go back in time and try and stop the one who got away from marrying that guy she went out with on a date once. Or maybe you go back in time and give yourself a winning lottery ticket so you're rich in the future. So all these people, if you discover time travel, are going to go back in time and they're going to try and do the impossible. They're going to try and do these paradoxical things. But we've just learned what happens, right? If you get that, loads and loads of people are going to find things happening to stop them. So the person who goes back to shoot his grandfather has a stroke. I'm there trying to stop the love of my life going out with some guy, and just at the point where I'm about to do it, I meet this girl called Holly, and I'm like, hey, yeah, you seem cool. I won't change time, I'm going to spend the rest of my life with you. And your lottery ticket, some seagull just swoops down and takes it off you. Something is going to happen to stop it from happening. So that's all really unlikely, right? The idea that loads and loads of time travelers will have loads and loads of unlikely things stop them, it's going to be tiny. Let's just say it's that tiny little number there, 0.0001%. It's just really tiny. So quickly recap what the score is. You're the reporter, you're watching the scientist about to discover time travel. There's a 0.1% chance of the asteroid hitting the Earth. If it doesn't, of which there's a 99.9% chance, then almost certainly a load of people are going to go back in time and try and bring about contradictions, and the chance of them not bringing about contradictions is really tiny. And you know that won't happen. You know, just as much as you can't shoot your grandfather and 2 + 2 = 5, and blacksmiths can't make round squares, you know that's not going to happen. So time for a tiny bit of maths. I'm sure it won't scare you. Okay. Here's a tiny bit of maths. Okay, real tiny bit of maths. So what's the chances? Chance of asteroid hitting 0.1. Chance of the asteroid not hitting 99.9. Chance of it not hitting, tap loads of people going back in time. Really unlikely things happening, like seagulls and girls called Holly and random strokes. Well, it's the chance of the asteroid not hitting times by the chance of the really unlikely events if it did, which is 0.00099. What's the chance of it not hitting and us going back in time and bringing out a load of contradictions? Well, it's just the chance of the asteroid not hitting multiplied by the chance of those unlikely things not happening. So, what goes on now? Well, if you know anything, you know that's not going to happen. That's definitely not going to happen. And just as it was with having strokes when we try and shoot our grandfather, the chance of the other things go up proportionally. So we can ignore that one. But the chance of the other ones go up proportionally. The chance of the asteroid hitting is 100 times more likely than the really unlikely banana peels stopping us bringing about paradoxes. So that means that once you've taken into account that you can't do the impossible, as you're sitting there in the room watching the scientists about to discover time travel, in the same way that you should think your chance of having a stroke has rocketed up, the chance of the asteroid hitting us has rocketed up to 99%. And the chance of the really unlikely things happening has rocketed up, but only to 1%. So as you're sitting there watching the scientists about to discover time travel, you should be expecting a massive asteroid to come down and hit you if these are the numbers you're playing with. So basically, far more likely that we all die, one single event wipes us all out, which stops the contradictions coming about, then lots and lots and lots and lots and lots of really unlikely events come about to stop us bringing about paradox. So this is key, because this applies to the alien civilizations as well. So now we can go back to those aliens who aren't there. Now I said the chance of them all dying out before colonizing the galaxy was really unlikely. What are the chances that disease or war and asteroid impact wipes out every single alien race before it gets to the stars? Well, it's very, very low. But now we see that we change our probability in light of this. If they're the kinds of guys who are going to go to the stars and time travel is possible, they're the kind of guys who are going to discover how to travel in time. And they're going to be the kind of people who go back to try and shoot their alien grandfathers. They're going to be the kind of person who goes back to sort out their alien love life. Or God knows what, who wants to know. Or they're going to be the kind of person who goes back to try and win the alien lottery. And we know that they're going to fail. We know the best explanation for that failure is that some sort of asteroid or some sort of single event is going to wipe them out. You should initially think the chance is quite low, but in light of what we've learned about time travel, you should now think the chance is quite high. Ooh. Sorry, skipped a slide. So the chance is now quite high. So us, what about us? Well, one last sobering thought is that you'd better hope yourself that the discovery of time travel is a long way off. Because if it isn't, then the biggest and best banana peel of all, the one that will stop, people going back to put like what went wrong, going back with sports almanacs, trying to seduce people via time-travelling letterboxes via lake houses. The best explanation for why none of that is going to go on is a single event that just wipes all of us out like an asteroid impact, taking us all with it. And that's it.